Permutations and combinations. In mathematics, objects often have to be ordered, arranged in different ways. In some instances, the order matters. In other instances, the order does not matter. That is the difference between a permutation and a combination. Permutation is the arrangement of items in which order matters. Number of ways of selection of arrangement of items in which order matters, NPR, is equal to n factorial divided by n minus r factorial. Combination. Combination is the selection of items in which order does not matter. The number of ways of selection of items in which order does not matter, n choose r, is equal to n factorial divided by r factorial times n minus r factorial. How do permutations and combinations differ? Take a look at these two scenarios involving 8 people. Scenario 1. In the Olympic 100-meter final, there are 8 competitors. In how many ways could the race finish? In this scenario, order matters. Who finishes first, second, and third and gets the gold, silver, and bronze matters. First place. There are 8 ways of finishing first. Second place. There are 7 ways of finishing second. Third place. There are 6 ways of finishing third. The ways the race could finish is equal to 8 times 7 times 6, which is equal to 336. So there are 336 different ways gold, silver, and bronze could be given out. So 8p3 is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1, which is equal to 8 factorial divided by 8 minus 3 factorial, which is equal to 336. Scenario 2. A committee of 3 people is to be chosen from 8 people available. How many different committees could be formed? In this scenario, order does not matter. That is because a committee ABC is the same as the committee BCA. They just happen to have been chosen in a different order. So in this scenario, we also have to divide by how many ways 3 committee members can be chosen. So the number of committees is equal to 8 times 7 times 6, the ways you can pick the 3 people, divided by 3 times 2 times 1, the ways in which 3 people can be ordered, which is equal to 336 divided by 6, which is 56. So 56 different committees can be formed, choosing 3 people from 8. So 8 choose 3 is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1, which is equal to 8 factorial divided by 8 minus 3 factorial times 3 factorial, which equals 56.